Yes, welcome to part two. Um, Yesterday I had promised to do threading, to show you how to do threading, um, threading 1.1. Then we'll be also doing threading 1.2. But before we do that, I will show you how to add second coordinate system of the Mark 1 and Mark 2. So just click on add. But before you do that, maybe let me show you the procedural way. So here is where the coordinate system is. How many mark do you want to add? So we have Mark 1 on this side, Mark 2 on this side. So you right click, then say open. Once you open, this is Mark 1, which is here, then this is Mark 2, which is here. When you click on it, it shows here Mark 1, Mark 2. So on Mark 1, you can edit, or you can add. For example, if I want to add another mark, click here mark, I put another 3, then I click on this face, ensuring that you have the place, when you are placing the coordinate system origin, you check that you are using the center of the revolving face. That's how you add the mark. So today we'll be doing the threading first, then next we'll also be doing the internal turning on the other side using mark 2. That is in SolidCAM. So for drilling, this is what we did yesterday. Maybe I'll show you the operations for until here. For our yesterday operations, we use this. Show you how we did this one yesterday. Let me rotate this one. Maybe people can see it. How we did our drilling yesterday. This is what we did. Okay. Rotate this one. Yeah. Let me just rotate it so you're able to see. Then I can use this one a little bit. You play. That is it. That's what we did yesterday. That is a drilling on using Mark 1. I've also added threading before it goes to the second mark. But second mark, I have not changed here this one. I will also show you how to change it, because it will now plunge into the jaws, because I have not changed the climb position for second mark. So let's do the simulation, but I'll show you how to change the second mark on this part, so that the tool doesn't plunge into the jaws. Because now using Mark 1. Now, if in case I go to Mark 2, the jaws may plunge in, the tool may plunge into this jaw. So I need to change on Mark 2. So, okay, let me also go up to this. All of this, let me pick all of the operations. Then you see how it will plunge into the jaws, so that we can able to change the jaws, the jaw locations. I can change this one to be like this. Let me play. Again, that is for Mark 1. Then Mark 2, it will plunge into this jaw. So what should we us do? I will now edit and locate a new position for Mark 2, so that it doesn't plunge into the jaws. And now I want just to simulate, then you see how it will plunge into the jaws, which is very wrong when you're programming and even when you're cutting. So let it do the turning first, finishing threading on using Mark 1, then Mark 2, which have done drilling. I'll show you how to do it. That is finishing using Mark 1. I've put two types of finish. That is two spring passes. Two spring passes. That is a threading. That's a threading. This is a threading it's doing. Threading. Let me rotate this one, you're able to see what it's doing. This is what it's doing. A threading, you see, is a threading. Is what it's doing. I'm able to rotate this one, you can see what it's doing. It's for threading. Simulation may look awkward, but when you put it on a machine, it will just do the real job. So this is the threading. It's doing a threading. Okay. Then next, you can go the second operation here. You see, I wanted to show you how it will plunge the material, but already it has done. So maybe uncheck these two. Then I show you how to plunge the material. Why there's a need to change. Why there's a need to change the positioning of the jaws when you also change the second part, because it will not detect this side but take this side. So let me do the drilling very slowly. You see what it be doing? It is doing the wrong side. Since I need to, you see it here, it has said warning collision detected. Why? It is detecting the wrong side, not this side. Since it will turn the other side so that you do turning. So how do we solve this? First of all, let me uncheck this from here on the setup. I want to go to edit. I want to go to edit. Let me check. Click here. How many? It has only mark 1. So you can change to mark. So here you can click on the mark, then you change which position you want to put uh, the jaws. So I can change to mark 2. Then from mark 2, I say pick. Here I can pick Z. So I'm assuming I want to clamp from this side. I'm clamping up to here. Yes, hii material itakuwa imeingia, or I can clamp here this side because itakuwa tumefanya turning. So I can put minus 40. Sorry, this side we have done turning, so I can put minus 45. So I'm holding this side. Okay. So that is for mark 2. Even where it is, you see it has already oriented. So I can put here maybe 44. Go back. You see, if I put a value 40, it goes back. So I want to put 45. So that is for mark 2. So I've hold mark 2. So that's how you change for mark 2. So that the tool should be changing depending on how you are clamping. So if I minimize this, I want to do only for mark 1. Let me edit this one threading, because this is what I wanted to show you how to do threading. This is where geometry is. I can click a new, show you where to clamp, where to do it. So new. I want to put from point to point. I want to start from this side, maybe somewhere far away. This is the geometry. I can start from here. Maybe from here, let me take, this is the coordinate, so I can take somewhere far away. Pick from here as it goes. So this is the coordinate, this is the point I picked from here, point to point, one by one until the last one. So in case I want to extend it far away, I can also start from here, then I go, so that the tool will be coming from far away. So I can pick somewhere here, a point, somewhere here, then I go all the way. So that's how I picked my coordinate geometry. So that's how I picked my coordinate geometry. If I click show, this is what I had picked. So you pick one by one. That is one way. Then a tool, I also check the tool here. My tool, it is, I'm using 16 ER, E meaning external right tool for threading with angle 60, pitch of 1.5. Then you ensure that you orient your tool to be along X axis, that is X positive, because the tool will be approaching from X positive, depending on your machine. Okay, then here some parameters are put. Minimum for should be 400 speed, 400, same 400, put it 400, 100, same here 400. Okay, put here 500, no problem. Okay, so once you do that, you select okay. then you can go to this one. The mouse was trying to reconnect. So you can go to level. Level put it far away from 5. Technology. My technology, I'm using these parameters. So it already calculated itself. So here I'm using millimeter. This millimeter, that's metric profile. Then this TPI, that is two per inch. So my pitch is 1.5, and my maximum diameter is 16. So 16 minus 1.5 get 14.5. So I put close to 14. I put 40.6, 40.7, 40.5 will be within the range. So some people normally take 15 minus what? 16 minus 1.3. They normally take a pitch of a difference of 1.3 to subtract, so that 0.2 is far away, which is meaning for cleaning of the material. But I normally use 1.5. So that's how you do it. If you want to do multi-start, you can also put number of starts when you're clamping, it becomes easier. Not just like when you're putting with one start, you try to find where the thread starts, but you can put a number of starts. If you want to three, like if it's 4, it's 360 divided by 4, that is 90 degree. It will change by 90 degree. If it is 3, it is 360 divided by 3, which is 120. So, but normally use one start. For this one is one start is okay. The link from there you're able to calculate. Once you calculate, it will give you the profile. So this is the profile where it is. So I want to do a simulation for this part. All of these operations we did yesterday until this. You hold down shift, then pick all of them. If I don't want to pick for Mark 2, then from here you come here, then you say you want to use SolidCAM simulation. But there's one way, maybe you see this one now. Why the jaw is here? Because I've picked the second mark. So what you do is, before you proceed, you come to setup here, right click, say edit, so that you can use mark 1. So here, check here, then activate mark 1. Mark 1, because mark 1 was at 120. So ensure that you put mark 1 back. Yes. Then you can rebuild. Once rebuild, click on this up to here. Then that is just shift down, select all of them, then do assimilation, so that you're able to see where the mark is. Now you see where the jaws have changed, because when the jaw was here, it will be crashing every time. It will be crashing every time. I want to rotate this one. People can able to see this one is doing the turning. Okay, a little bit. Okay, then I can increase the speed a little bit, then run. So that is what it's doing now. Yes, you can see what it's doing. Yes, that is a rough turning. And I've also put that in case of any groove, it will do actual and groove turning, so that it goes where there's a material for grooving, but where the tool cannot plunge into, it will leave an extra material. That's why here you're supposed to be doing grooving, but it has left some material. So what to do is the grooving tool will be easier to come just and to finish the material without now machining from the start. Now this is the finishing operation. And then remember, when you're designing your shaft, if it is a shaft which to be used in a very critical area, prevent using sharp edges where the two meet. Like between this one, between this one, ensure that you prevent using sharp edges. Okay. Now this is the threading. Maybe I can expand it a little bit. This is the threading. You have seen, this is what we are supposed to do today for today's session. So it is doing now threading. So doing now threading. This blue one is for the hollow part, which there's no need for now. This is the threading, what is doing now for the threading, using SolidCAM, And then this is the material. It has machined, it has the final part. In case you see somewhere there's a material which is left, ensure that your tool you're using for turning has the radius that corresponds to what it's supposed to do. But if in case it leaves the material, then you can use even a grooving tool to do turning. So that because your grooving tool is square-sided, or even has a simple radius, use the one which is without, which has a radius of 0.1 to do your groove turning, so that you ensure it doesn't leave excess material on their part. Designing is very critical. Also ensuring that when you are designing for manufacturing. You are just not designing for the case of designing. If you are designing for casting, design for casting. If you are designing for 3D printing, ensure you factor in the tolerance for 3D printing. If you are designing for machining, that is CNC machining, ensure that you design it for machining. If it's laser, plasma, or jet, or all those kind of operations of machining, ensure you balance the tolerance for each operation so that you don't incur a lot of excess material or inequalities in terms of the material uniformity when the tool has done its operations. So this is what we do. So the, today's was supposed to do threading, and this now we have accomplished our operation for threading. Thank you. I can proceed to show you. So this is what we have done today. I show you that we are going to do threading because yesterday we did these operations from here, this one, drilling, facing, rough turning, grooving, finish turning. Now today we have done threading. How you do threading is very key when you're seeing what SolidCAM. So welcome and have a lovely day. Enjoy your time, enjoy your weekend. And if you want to learn more, follow my tutorials. Where I make an error, you correct me. That's how we learn. Okay. Thank you.